stop me at any time.
Okay, sir.
Okay, sir.
So, this is syllabus for us. Unit 1 is solution thermodynamics. Unit 2 is solution thermodynamics applications. Unit 3 is vapor liquid equilibrium, which is mostly used in distillation. This is up to your in-sem exam. And then Unit 4 is phase equilibria, which will cover liquid equilibrium and solid liquid equilibrium. And Unit 5 and 6 are chemical reaction equilibria. And 6 is also for chemical reactions. So 4 units on phase equilibria and 2 units on chemical reactions. So I had asked requested some, right? And I heard that many students have registered. Really happy to know that. But I have also requested that you go there when you log in, you select me as your mentor so that I can track your progress. And I checked, I think 2-3 days ago, there were only 2 or 3 students who had selected me as their mentor. So is there any difficulty? You are not able to select, you are not able to see me as mentor, or is there something else? Please speak up. Then put in chat if you want. What is the difficulty which you are having in selecting me as a mentor?
Where, sir?
Sir, that option is not available on the phone.
Yeah, on the phone it is not available. So if you have a laptop, you can select me.
Sir, I've done that.
What is it?
I've selected you as mentor.
Yeah, so I know I talked with the librarian and she did mention that on the phone, on the app, it is not available, that option. And she is communicating with NPTEL to convey this message. I don't know how long it will take them to change the app, but if you have access to a laptop or a PC, you can do it on that medium. Okay. So please
Okay,
select
sir.
me as a mentor so that I can see your progress and I can help you also.
Okay, sir.
Okay. So you can use chat to communicate if you're not using your audio. Anyway, it is fine. What is slide number now?
6.
Okay. So NPTEL syllabus, if you see, it's an 8-week course, and it's a course called phase equilibrium thermodynamics, and it will cover mainly our first four units. First 4 units are about phase equilibrium. So that is what is the syllabus for NPTEL course. It will not cover the last 2 units of our syllabus. Those last 2 units are not that difficult to understand, and that's why I recommend that you take this NPTEL course. Okay. So textbooks which you'll use is mainly Narayanan I'll be using, which we have used in CET 1. I don't know whether used in CET 1 or not, but I'll be using Narayanan, and sometimes I'll use Smith also, because many times problems come from Smith. So we'll cover both, because mainly on Narayanan and some portion from Smith. So now coming to our, this is part of the introduction. You should be aware of what is the mission and vision of the college and department. And that's why the first lecture I normally devote to this. So vision of the society, SMS is service to society through quality education. And the mission of the institute is our College of Engineering. The mission is generation of national wealth through education and research. So essentially what we are doing is we are educating the next generation, and through that these people, you graduates, are going to be basically working in industry, working in research, working in various areas, and that is how we are helping generation of national wealth. And next one is imparting quality technical education at cost affordable to all strata of society. The society tries to maintain the reasonable fees if you can afford it. Enhancing quality of life through sustainable development. Again, this is going to be through all the graduates and through all faculty when they do research. Okay. Carrying out high quality achieve the distinction of highest preferred engineering college in ISO state. This is done through various activities, co-curricular, curricular, extracurricular, and other activities in which then the department vision and mission. Chemical engineering department, your bachelor's degree is basically the foundation on which you can build. You can work in industry, you can do research, you can do masters, you can do PhD, then do research or join academia. Second mission is to analyze and solve problems of chemical industry and society. This is again through graduates and through faculty. Okay, so next is program education objectives. These PEOs are defined in NBA. We are going to go for NBA accreditation, which is National Board of Accreditation. And the PEOs are essentially what the graduates would demonstrate a few years after they graduate. Once you finish your BE and start working, maybe 3, 4 years, 5 years down the line, what kind of traits are you going to exhibit? First one is competency. So our objectives as a chemical engineering department is to make students competent in fundamental principles of science and chemical engineering and train them in modern experimental and computational skills. So we cover all the basics of science, physics, chemistry, maths, and chemical engineering, and use experimental and computational. So you have labs and you have what do you call simulation programs or programming languages like MATLAB. So these are all skills which you learn. Second is problem solving. Educate students to identify, analyze, research, and solve chemical engineering problems of practical importance to industry and society while taking into consideration ethical, safety, economic, and environmental factors. So when you're solving a problem of industry, you have to keep everything in mind: ethics, safety, economy, and environment. And last is leadership. Develop effective communication, teamwork, and leadership skills in students so that they can play effective role in industry and research institutes. And all these leadership skills you develop through various activities, mostly extracurricular activities or co-curricular activities by participating in competitions, paper presentation, etc. And these are the various skills which you or traits which you exhibit, which you are expected to exhibit after graduation. So The vision and mission, just defining it is not enough. We need to disseminate it, and it should be disseminated to all the stakeholders. Stakeholders are students, parents, alumni, industry, everybody. So how do we disseminate this? So in the induction program for first year, the principal communicates institute vision and mission, and then in the department, the head of department or faculty discuss institute and vision department mission session POs with SET and B students, like we are doing now. And then during interaction with alumni, parents, and industry personnel, we have meetings organized for alumni, parents also, and we discuss these things. And in the department or in the college, these are disseminated through department office. These are vision, mission, and everything displayed there. The labs, classrooms, currently they may not be there, but we are going to do that. Seminar hall, notice boards, department website, lab manuals. We write every for every lab manual, lab journal, and newsletters. Okay, so what is the process of defining all these things? POs, vision, mission. So we start with institute vision and mission. Then we do brainstorming in the department. All the faculty members discuss, and we prepare a draft for the department, mission and POs. And then we review with stakeholders like management, the department advisory board, which comprises people from industry or eminent people from industry, research, and academia, students, parents, employers, alumni. So whenever if there is any feedback, you again go back and revise it. So essentially, this is our feedback collection mechanism, and I'm sharing this with you. So if you have any all these things, you can share with me now or later. You can send your comments or suggestions through email or through WhatsApp, whatever medium is available. So does anybody have any comments or suggestions on all these things? No? Okay, so we'll move on. We have a mapping of the program education objectives and mission 1 and mission 2. And 3 means highly dependent or high correlation. And 2 means medium correlation. So PO1 is strongly correlated with mission 1 and mission 2. Whether PO2 is strongly correlated with mission 1 and 2. And PO3 is moderately correlated with mission 1 and mission 2. So PO1 was competency, PO2 was problem solving, PO3 was leadership. And mission 1 was developing students for industry, academia, and research. And mission 2 was solving problems of industry and society. This is the correlation. And this is justification for the correlation. By developing competency in graduates, we'll be able to prepare graduates for solving problems of industry and society. That is why it is strongly correlated. And by developing problem-solving skills in graduates, we'll be able to prepare graduates for solving problems in industry. Again, strongly correlated. By developing effective communication, teamwork, and leadership skills in graduates, we'll be able to prepare graduates for solving industry problems and society problems. Moderately correlated. Next, we come to program-specific outcomes. Now, these are the outcomes which will happen or which should happen immediately after you graduate. That means once you finish the 4-year course, you'll be able to identify, analyze, design, and develop solutions to chemical engineering problems of practical importance to industry and society, and demonstrate sound understanding of chemical engineering fundamentals, solve problems through the use of modern experimental methods, computer-aided design, and simulation software. So we have a lot of subjects in second year, third year, and B, which focus on chemical engineering, mass transfer, heat transfer, design, reaction engineering, and we have a project in B on which you apply all these concepts you learned. And if you have a theoretical subject, design project, then you apply all the concepts to the material balance, energy balance, design the equipment for unit operations and for reactor, and you do costing also, economic analysis. So all these things can be applied in your project, and that's how you'll be able to solve problems of industry and be prepared for it. Next is program outcomes. These are defined by NBA, National Board of Accreditation. And these are attributes which every engineer will have after graduation. This is irrespective of branch or discipline. It's common for all branches of engineering. So first is engineering knowledge. Apply the knowledge of mathematics, science, engineering fundamentals, and an engineering specialization to solution of complex engineering problems. So whether it is chemical engineering, mechanical engineering, or any other engineering, you should be able to solve complex engineering problems. Problem analysis, identify, formulate, review research literature, and analyze complex engineering problems, reaching substantiated conclusions using first principles of mathematics, natural sciences, and engineering sciences. You can take the problem, review the whatever is available, literature available on it, and analyze the complex problems. Once you analyze the problems, then you design and develop solutions. Design solutions for complex engineering problems. Design system components of processes that meet the specified needs, appropriate consideration for the public health and safety, and the cultural, societal, and environmental considerations. So design solutions, keeping everything in mind, like ethics, environment, economy, everything. Conduct investigations of complex problems. Use research-based knowledge and research methods, including design of experiments, analysis and interpretation of data, and synthesis of information to provide valid conclusions. Then modern tool usage. Create, select, and apply appropriate techniques, resources, and modern engineering and IT tools, including prediction and modeling of complex engineering activities, and understanding of the limitations. So you'll learn a lot of tools. You can use MATLAB, you can use simulation software. All these things you can use to solve problems. Engineering society, apply reasoning formed by the contextual knowledge to assess societal, health, safety, legal, and cultural issues, and the consequences relevant to professional engineering practice. Environmental sustainability, understand the impact of the professional engineering solutions, societal and environmental contexts, and demonstrate the knowledge of and need for sustainable development. Ethics, ethical principles, and commit to professional ethics, responsibilities, and norms of engineering practice. Individual and teamwork, function effectively as an individual and as a member or leader in diverse teams and multidisciplinary team settings. So work as an individual on your own and as a part of the team. Communication, communicate effectively on complex engineering activities to engineering community and the society at large, such as being able to comprehend and write effective reports and design documentation, make effective presentations, and give and receive clear instructions. So all these things you'll practice in your project project, e-project. You do this in your lab reports also. Project management finance. Demonstrate knowledge and understanding of engineering and management principles. Apply those to one's own work as a member and leader in team to manage projects and implement discipline environment. So you will apply this in your project also. Lifelong learning. Recognize the need for have the preparation and ability to engage in independent and lifelong learning in the broadest context of technological change. Essentially, is to be able to learn anything on your own, any new topic, so that mindset is there and you can solve the problems. So these are all related to NBA. We have vision, mission of the institute and the department. We have the objectives, specific outcomes, and program outcomes. You should be aware about all these things. Any comments, suggestions on all any of these? Okay. So next I will do brief revision of first law of thermodynamics.
Okay, sir.
So what is first law of thermodynamics? You have done CET one, right? So I would like you to tell me what is first law of thermodynamics. Chat window is open, right? You can chat.
So the
Not some
chat window isn't open for students who joined as guests.
what is it?
Yes, sir.
I can't hear you.
Am I audible?
Yeah, I can hear you now.
Yeah. So the chat window isn't open for the students who have joined as guests.
Oh, for the guests. Oh, okay.
Yeah.
Okay, so I don't know how to do that. Maybe next time I will enable it, find out what is there is a setting. But others who are joined, who are logged in can chat, right? Are others able to chat? Those who are logged in with your proper credentials.
No, sir.
Nobody is able to chat?
No.
Okay, then audio is available, right? So you can talk. What is first law of thermodynamics? Anybody? Ravindra? Ravindra is there or not? करुणा के इसमें चक्कर में Hmm? Nobody knows what is first law. Dikshita?
First law.
So Q is equal to U plus W.
What is it?
Sir, total energy should remain constant.
Hmm.
So the first law
Conservation
of
of energy, right?
thermodynamics is an expression of conservation of energy.
Yeah, conservation of energy, right? So energy can change form, right? It's not destroyed, it cannot be created, right?
Yes, sir. Yes, sir.
Yes.
So change in total energy of the system is compensated by an equal and opposite change in the total energy of the surroundings. So if we take the
Yes.
system plus surroundings, total energy is going to remain constant,
Same.
right?
Yes.
Can you see this slide? Slide number 3. No?
No, sir.
Okay, so I have to share, stop sharing that one and share one more. Can you see this now?
No, sir. Ah,
Yes, sir.
yes.
First law of thermodynamics, can you see?
Yes, sir.
So that is first law of thermodynamics, conservation of energy. So what is the statement of first law of thermodynamics?
Change in total energy.
Change into into-
Delta U equal to Q plus W, or delta U is equal to Q minus W.
Hmm.
Which say heat is supplied to the system, that is positive, and work done by the system is taken as positive. This is one sign convention. Delta U is nothing but how much heat is supplied to the system minus how much work is done by the system. What is the input? Input is heat supplied to the system, and output is work done by the system. So Q minus W. All other one is whatever is supplied to the system is taken as positive. So heat supplied to the system is taken as positive, and work
Hmm.
done on the system or work done
It's
into the
positive.
system is taken as positive. This is sign convention, and that is in that this case it is delta equal to Q plus W. Any doubts, questions on this sign convention? There are two sign conventions. Answer is going to remain the same. Numerical value is going to remain the same. Only the sign convention is different. In this case, Q is positive, supplied heat to the system. In this case also Q is positive and heat is supplied to the system. So both these are positive supplied to the system. The difference is work done in this system, the whole system is done by the work done by the work is taken as positive. And in this case, new one work done on the system is the only difference. Anybody has any questions on sign convention? Because this is the most confusing part in most of the cases. Engineers are particularly interested in heat engines for pumping water or driving machinery. The desired output was work and the required input was heat. It made sense to consider both as positive. So what was work done? Like you take steam engine. Steam engine what does it drives a locomotive. So work done by the steam engine was taken as positive, and heat supplied to the steam engine through burning of coal was taken as positive. That's why it was delta U equal to Q minus W. Increase in internal energy is nothing but excess of heat supplied over work done by the system. Second sign convention is non-English speaking word, the latest one. Currently, most of the places this is followed. But in Naran and old convention is followed, so we'll follow old convention. In this case, heat and work are both taken positive and the direction is into the system of interest. So whenever heat is supplied to the system, it is positive. Work done on the system from outside is also taken as positive.
Yeah.
हेलो
Not spend much time. If you have any
सर एक
questions,
डाउट था
yeah.
सर जो हीट है ना वो कभी नेगेटिव हो सकती है क्या मतलब हीट सप्लाइड या सिर्फ पॉजिटिव ही लेते हैं
Okay.
The heat.
Who is this?
हेलो
Tell me your name. Don't be afraid. Tell me your name.
सर माय नेम इज देवेंद्र मोरे
देवेंद्र बोलो. हाँ बोलो फिर से रिपीट करो क्वेश्चन.
सर जो हम हीट सप्लाई लेते हैं ना सिस्टम में तो वो कभी नेगेटिव हो सकती है ना या से हमेशा पॉजिटिव ही लेते हैं हम
See, positive, negative is only a matter of direction.
ओके
Right? It's a sign convention. Heat is never negative.
अच्छा
Heat is always positive. Work is always positive. यानी काम होता है. Right?
हाँ.
अगर मैं यहाँ से चलकर कहीं जा रहा हूँ तो काम कर रहा हूँ. Right?
हाँ
I'm expending energy. Right? I'm doing some work. अगर मैंने कुछ 5 किलो का वजन उठाया. Right?
हाँ
I'm doing some work.
ओके
Work is always going to be positive. Positive or negative, जो sign convention tells us only direction of that work or heat.
ओके ओके
Just indicating कि किस direction में जा रहा है. अगर positive है Q, that means we are supplying to the heat system.
हाँ
Right? अगर negative है that means system is supplying heat.
हाँ बराबर यस सर ओके
The system is working ऐसे heat steam engine चला तो क्या it is doing work on the bogie. उसको कहीं लेके जा रहा है. So it is work done by the system, that is steam engine on bogie. बराबर. So that is taken as positive in the old convention. In the new convention that is taken as negative. It's just positive, negative is nothing. Numbers will not change. मैं बोल रहा हूँ. It is only a direction जो है बता रहा है.
ओके
It's just a naming convention कि हमारा किस direction में जा रहा है. When I say old convention, Q is positive. That means I am supplying heat to the system.
ओके
But if I say minus Q, that means heat is supplied by the system to the surroundings. Similarly, work done लिया हमने old system में तो work done by the system on the surroundings is positive.
हाँ
Work done by the surroundings on the system is negative. It's only direction which is plus minus is only for direction.
ओनली इंडिकेटिंग द डायरेक्शन ओके
Only indicating direction. Convention नया लो या पुराना लो, it's only indicating direction. That's all. Nothing. Numbers, quantity is going to be always positive. ये वर्क नेगेटिव हो ही नहीं सकता. हो सकता है कि वर्क नेगेटिव कभी
नहीं वैसे नहीं होता
नहीं हो सकता. हेट भी नेगेटिव नहीं हो सकती बिकॉज इट जस्ट सेज कि डायरेक्शन क्या है, किस डायरेक्शन में जा रहा है. हीट कहाँ से कहाँ जा रहा है, सराउंडिंग से सिस्टम में जा रहा है, सिस्टम से सराउंडिंग में जा रहा है. सो वर्क सिस्टम से सराउंडिंग में जा रहा है कि सराउंडिंग सिस्टम में जा रहा है. दैट्स ऑल. Indicator only direction. Sign convention is only for direction of flow of heat or work done. समझा गया देवेंद्र? कुछ और डाउट है?
समझा
और किसी को डाउट है? बिकॉज this is always very confusing. Sign convention. You can take any sign convention. Doesn't matter as long as you say this is according to new sign convention or this is according to old sign. इतना mention करना चाहिए आपको. You give an answer. It is according to new, because that is important. Old sign convention में verb का अलग है और new sign convention verb का अलग है. Q का same है दोनों sign convention में. Q का direction same remains same in old and new convention. Only verb का change हो जाता है. New convention में it is work done on the system is taken positive. Old में work done by the system is taken as positive. As long as you understand that convention क्या है, old है कि new है, and then mention that. ठीक है, और किसी कोई डाउट है, क्वेश्चन है? So I will not go into detail. Let's see second law of thermodynamics में क्या है? Can you see the second law of thermodynamics PPT?
Yes, sir.
So again, second law में सिर्फ sign convention का problem रहता है. What is the second law of thermodynamics? Yeah, किसी को?
It's a heat flow from higher level to lower level.
Okay. Good. That or
So heat will not flow from a lower temperature to a higher temperature unless and until work is being done on the system.
yes. Good. What was that?
Sir Nupur.
इससे पहले
Sir Praveen.
Okay. So essentially what it means is if you heat transfer or see first law only tells us about what is the quantum of work done or heat transfer, right? Q and W. You can calculate that, but doesn't tell which process is feasible, which process is not feasible. First law does not tell us, right? If waterfall is there, water will always fall from the top to bottom. Waterfall, right?
Yes.
नीचे से ऊपर नहीं जाएगा कभी. But first law does not indicate whether some process is feasible or not. It will just say कि हाँ Q इतना है, W इतना है, delta U इतना है. Whether that process can take place or not is not indicated by the first law, right? Like heat transfer from higher temperature to low temperature intuitively हमको समझता है कि होगा. But can heat transfer take place from low temperature to high temperature? First law doesn't tell that. That's why we need a second law of thermodynamics to tell us what is the direction of flow or whether the process is feasible or not. Right? Like work can always be converted to heat directly, but reverse is not true. Seven. Can heat be converted to work? completely. No. So, limitation of first law also calculate energy changes, but it does not place any restriction on the direction of a process. So, first law may be satisfied, that does not mean the process actually can actually occur. नीचे से ऊपर कभी नहीं जाएगा. Right? So we need to have another term called entropy for understanding all those things. So a process can occur only if it satisfies both first law and second law of thermodynamics. Then only you can say that process is feasible. Okay, so for this heat source and heat sources, any reservoir which is maybe at temperature can transfer it to lower temperature. जिसका heat transfer जो होता है source to sink, higher temperature is source, lower temperature is sink. Heat engine देखना पड़ेगा, so I think we need more time. So tomorrow we'll take up this more in detail and we'll cover second law. So any suggestions or feedback on how we are conducting these classes? कैसा difficulty है, क्या हो रहा है? What do you think? Anybody?
Sir, this is Nipur. Approximately for how long will we be having online lectures, and when is college physically gonna reopen?
I don't know the answer to that question.
Okay, and so what about exams?
I don't know the answer to that question also.
Okay, thank you,
See,
sir.
it depends. See, you are aware of what is the status of COVID, right?
Yeah.
So it all depends on how fast we come out of it. I think that's what the key is. Schools and colleges are going to be maybe the last to open.
Yes.
Especially schools. Colleges may be earlier, but schools, small children will be the last to open.
Yeah.
Yeah, schools will open first, colleges will open first, but schools are going to be very, very difficult for them to open. So college also, unless COVID situation is under control and we have more confidence, because it's a lot of interaction, that you cannot keep social distancing in classrooms.
Right, sir.
That is the reason why we are doing these online classes. We have few more people, then we can start online classes, or rather, regular classes. Any other questions? Shivani, have you prepared the list of students who don't have the login ID?
Yes, sir.
Shivani? Shivani there? Yes, no. Shivani, can you hear me?
Yes, sir.
Shivani? Can't hear you there. Okay, so we'll meet tomorrow. The timing will be different. As per timetable, I'll send the invitation in Microsoft Teams and you can join. Okay. Have a good day.
Okay, sir. Okay, thank you, sir.
Thank you.
Thank
Bye.
you, sir. Bye, sir.
Keep safe.
Yes. गेले का